Okay, hello everyone. Welcome to another Wolfram language design meeting. We have a variety of topics today, starting with a complicated one about handling annotations to map. So let's see, what do we have here? We've got...
So the red in those cases are symbols we don't have, but just showing we're interested in the variation on map or select.
That's interesting.
And
what would a function like association select do?
What would it do? Yeah, I mean, because it's got keys. I mean, select works on associations. What does association map do? It creates an association, right? From a map. I don't use it very much. I usually say association of, and then I just do a map with rules.
Oh, I use association map all the time. I use it constantly.
Well, I should use it probably. I'm not modern enough. Let's see. What is it? It seems like a better idea than what I do, which is association of map.
The first usage here is the good one. The second one's
right.
not as good.
The second one is the evil one.
But the first one is really useful, and I use that all the time too.
Right. Gosh, I should use that. I mean, I do that in 2 stages. Right. Okay.
And the second one is kind of just a poor man's key value map, that, association of key value map, basically.
Yes, except presented in a more bizarre way.
Yeah.
Okay, but what would association select do?
Well, I mean, I think, look, there's a table here, and maybe not every slot in the table is filled.
Yes, I see. Key replace. That's a weird one, because that's going to have all kinds of key collision issues.
Well, that's like what we talked about, having key map, giving it a merging function option.
Yes, which seems like a good idea.
Something like that too. Yeah.
Right. Okay. So 3 components to these variations. Which arguments are given to the function? By the way, I mean, there are things about map, for example, like there are different annotations to map. Like, for instance, avoid applying the function f based on a pattern to the thing on the thing that it is being applied to would be an example of something that would be, certainly be useful.
Don't transform missings.
Yeah, for example, yes. Or I mean, clearly you can write, if test, hash sign, otherwise,
well, I mean, what you're suggesting is, right, you just map the operator form of replace, right? The things you want to transform get transformed.
No, I know, but I'm saying that if all you're trying to do is transform like that, well, okay, what you're saying is, maybe I just didn't think of that way of doing it. I mean, what you're saying is that what I could do is I could just say map replace of, and then the pattern. That's a good idea.
So the things you want to stay the same go to themselves, and everything else, and blank goes to f of blank.
Yeah,
which is, by the way, equivalent to just replace with a level spec of 1, list 1.
Right. Yes.
But I mean, it ends up being something like this.
Yeah.
Which is a little weird, but not totally terrible.
Again, I think replace at level 1 is probably the better way to do that, but yeah, okay.
Yeah, I guess that's how I would normally do it. I was assuming we had.
Yeah, if you're in the map mindset, then yeah, right. And this is the. Although there are several other cases where it's not a pattern but a function. Like again, like there is a pretty common thing that I end up writing where it's if missing q of hash,
exactly,
then hash,
right.
Otherwise f of hash.
If test of hash, then hash, otherwise f of hash. Right.
I mean, we talked about stuff about doing that specifically for missings, making some sort of operator form thing. This is like years ago. We talked about having some operator form that would kind of, or like some headdressy. No, it was just an operator form that would do this.
Right. So this is like reverse applied. I mean, that would be something like reverse applied of f, which. So what would this do? This would be, non-missing applied of f of x.
Don't we have an LCC ticket from a couple of months ago assigned to you, Christopher, about this? I mean, there was one thing which was to extend missing Q with a second argument about, what sort, or I guess failure Q, what sorts of things we consider bad. But wasn't there also something?
Yes, there was. This is the thing. I mean, I haven't looked at that in a while, but I think that was more than a few months ago. That was like at least a year ago. Okay. But yeah. So I think we may have had something about this. So maybe we shouldn't launch into another discussion about it if we're going to remember that we already figured this out.
Look up the notes.
Yeah.
Right.
Avery, do you have the ticket number handy for that?
I can try and find it too, but it'll take me a second because I don't use Jira very much.
268, I believe.
Okay. So let's go back. So I mean that's one item. It's an interesting idea. I think this is an interesting idea. There's some kind of non-missing applied headdress.
I think test applied was the thing that we talked about before, looking at the Jira tickets.
Oh yeah, I remember that now.
F comma condition.
You are right. It was created November 2020.
Yes.
Okay, so I remember. I thought it was November-ish. I just had the wrong November.
Right.
I'm not sure the name is quite right, but it's an interesting function, it seems to me. I mean,
it might be nice if it also had a default, version,
yes,
which would be basically.
I agree.
Doesn't, yeah.
Right, which I think which would be similar to the confirms defaults, presumably.
Yes, I mean that was the other thing we talked about at the same time as this, was having a function that basically is like failure Q or missing Q. Well, actually, I think the idea was to extend failure Q so that it detects the same things as confirm or something like that, or at least having a second argument to failure Q that would let you detect the same things as confirm.
Yes, we should do that.
Yeah.
All right. But anyway, this seems like an interesting function, but it isn't the main thing we're talking about here. The main thing we're talking about here is this MetaMap notion. But what you're pointing out, in a sense, is that there's also meta select and so on as well. So, there's metadata enabled functions, basically. And what we would want is something like select list, comma, and then what would it be? It would be some kind of meta. I mean, just to have what the heck would it be? It would be something like meta enabled of the function f with, something, I'm just making this up a bit, but I mean, if we say f of #1, #2, and then the meta enabler would have as its keys here, expression and position, let's say.
Right. Well, I mean, I think that should be actually a pure function, right? You just added the ampersand. Okay.
Yeah. Right. But so then the idea would be that this is a general headdress. Could this work? A general headdress that knows, that is enabled by the outer function. I mean, this would be probably an up value story at first, at least.
I don't like the fact that functions like selected map are like blind functions. They have no idea. They just blindly are supposed to use that as a head. I mean, what if, for example, I wanted to make a list of meta-enabled option? I wanted to make a list where it's meta-enabled of blah, meta-enabled of blah, etc. How would I do that with map or with select?
Yeah, I know that's bad.
Right.
I mean, we got.
I guess you put the ampersand on the outside, actually, but still, I mean, like you have to jump through hoops a little bit to do it.
Well, the question is what meta-enabled on its own would do. when applied to, if you made the mistake of thinking select is going to just apply the meta-enabled function, what would that then do? What would that return? It would say it would probably be an error. I mean, it's like a throw, an uncaught throw. It only lives inside that environment.
I mean, honestly, I think that, I mean, there are two cases here, right? They're two different. There's the question of what gets passed to the function, and there's the question of what's like the fundamental behavior of this, of this,
Sorry.
right? So there's, for example, there's parallel or not. There's, do you wrap the thing in an association somehow? And then there's what gets passed in, like, do you get access to the index? I think that whether it's parallel or not, that sounds like it's probably a headdress thing, right?
Yes.
I mean, because that's just sort of changing the overall behavior of the function. Whether it returns an association somehow, I think that those should be different symbol name. I mean, those should be different function names, like association map, because each of those is a one-off. You have, I mean, if I tell you it's a parallel version of select, you can guess what that is. If I tell you it's an association version of select,
yeah, there's multiple things that could be done.
I don't know what that could be. And then this case about what gets passed in, I mean, is there a reason for this case that it couldn't be like an option to map or select or whatever? I mean, it wouldn't be the prettiest thing,
very much.
but
I mean, this case, okay, the alternative, the thing we're talking about here is perhaps going from, this is basically a named, some kind of named argument story. I mean, we probably don't want this case. This case is probably less interesting. This case is the interesting case, it seems to me.
What if meta-enabled wrapped the head instead of the function?
Well, that's what I'm thinking, yeah.
Meta-enabled of select, comma, property names.
Potentially property names if you need it, or
If you
it can
need it, right,
lexically analyze it.
Right.
I mean, it probably is in a position, I don't know whether it can pick it up correctly to lexically do it.
well, yeah, I think we talked about that last time, that
Yes.
that it should do that for performance reasons as well.
Right, but so then the full form of this might be meta-enabled of select, comma, expression, position, whatever. But it would be, what we would do is, we would try to do that automatically. We'd try to fill that in automatically.
What about functions? I mean, I'm not sure we have any examples of this, but what about functions that take multiple functions? Like if you had something like, fold pair list or something like that, or maybe not fold pair list,
Yes.
outer or something like that. I mean, it's hard to imagine how this would work with outer, but if you, do you understand what I mean?
Yeah, I understand what you mean. Is would it make all the functions with, I mean, it's like a curry type thing. You could potentially, but it gets very ornate to say meta enable this argument, but not that argument.
Yeah, and also the fact that different arguments might have different sets of keys that are available.
Oh gosh, yes.
So that's why it seems a bit strange to put it on the whole select.
Well, okay, so the choice is,
Well,
I think it will be harder for people to understand as a headdress. I will say that. Go ahead, what were you going to say?
Right. So I thought the point was that we want to sort of give a uniform set of, I mean, I think trying to have meta enabled for arbitrary functions like outer is just a lost cause, right? So my understanding of our project is we want to sort of give a consistent set of keys to, our sort of core operating sort of functions like, map, replace, select, maybe some friends thereof, like
Yeah, I mean, one thing I'd love to have is some in like for map indexed, one of the things I'm always frustrated by is having to say first of #2 all the time. And I would be much happier if I could say hash index or something instead of that.
Well, like if there was a hash index and then separately there's another hash something rather,
Position.
that's like that's like assumes it's step 1 and stuff.
Yes, that's what I'm thinking.
Yeah, sure.
That would be consistent with how nearest and take largest use the key index. It's
Yes.
just an unwrapped number.
Right, exactly.
And would that still be available even if you're mapping at levels other than 1?
Why not? It just means it's the first level index.
Okay.
Or the current level index.
Or the current level, yes, we'd have to figure that out.
I'd guess that current level is probably
more useful.
But yeah.
Unwrapped current level index.
So,
okay.
I mean, in another world, this can't work, but it might be nice if you could just do map and then, it just looks at the map and, oh, you didn't use #1, #2, you used hash expression. Okay, I know how to fill that. I mean, unfortunately, I don't think that can work because if you're mapping over a list of associations, you're doomed. But
right,
yes.
and also if you map, I mean, I suppose it would have to find the things, but right, you can also just map F, and maybe F eventually does something with these things. Well, no, that doesn't make any sense. Never mind.
Yeah. No, I mean, I think whatever solution we have, I think it would definitely, I think it would be best if you don't have to write the keys that you want, right? If it just lexically finds them, and then it can be documented under map, or maybe if we have this other head, what the, what keys work.
Yes, I think, well, okay. So first question is how many functions? I mean, if we're just dealing with map, if we were dealing with map, select, replace.
Maybe.
But I think there are many more than this. There are many more kind of functional programming functions or list manipulation functions.
Right. Yeah. So the name I couldn't come up with earlier is map thread. How does map thread fit into this story?
God knows. I mean, this is. I think there are many more functions here. Go ahead.
I have the impression that this can be generalized to something that looks at its wrapper and finds a position in itself. So that's this proposal in the last section of position applied.
Oh, well.
So I was trying to generalize, I don't know, splice and threaded, this type of thing. And so we can have something. This is just a name for a wrapper that knows what to do by itself. And then, of course, if it's placed in the first argument of map, then it can do more intelligent things.
What does it do by itself?
You can evaluate that. A value in the first line, and then you see what PF does by itself.
That's kind of neat.
So it's a bit like the idea of nothing. It looks at the wrapper head, and then it says, oh, I'm going to place myself.
Replace itself.
Exactly.
Yes.
So it knows that it has to, PF, position applied of F, knows that it has to look at the position it is, and then adds the position. And so if you map that function, it already does what map index does.
But how does it do it at the second level? Does it work?
Not this one, but map could add the position. So the idea is that if it has a wrapper that knows what to do with it, it will do a more intelligent thing. Otherwise, it still does something that may be useful in some situation. So for example, look at what replace does with it in the next example. I think that's interesting.
Sorry, where is this?
This echo where. Evaluate that echo where. And so you see, we just map that, and it's able to return the same thing, but in the process, it's saying, I have found this integer here.
Yes. So, I mean, we could imagine potentially, we could imagine a family of these things. So it could say, for example, it could be, say, index applied would give you the unwrapped thing. So it would be, say, index applied there. So map indexed, level 1 map indexed would be map of index applied F, list.
Well, following your previous idea, it could be meta applied, and then in a second argument, you say what needs to be added. Maybe the index, the position, or
Right.
something
The
else.
general case might be a meta applied
Right.
of this, comma, and then certain metadata,
Mhm.
which could be accessed either positionally. I mean, you could have a mechanism to either say that you could do this. Yeah, you could have a bank of things that you could access positionally here, or you could have something where it defines that that's #1 and something else is #2 and so on. Well, so go ahead.
Right.
Well, I was
so-
just going to ask back to what Itai was saying earlier about map thread, though. I mean, because in map thread, you kind of have to be able to use, hash and stuff like that. So there's sort of a question of, I mean, maybe there's one that's just called like hash expressions or something like that, which gives you like a list. It's a little bit inconsistent with how map thread otherwise works, where it gives you sequences and stuff, but I don't know.
Okay, so hold on. Let's go back here. This is a very interesting idea. So this, why were we not? So in select, for example, it would be select of range of 10, and then there it would say position applied of. Now, how would this work? It's position applied.
I mean, you need a function that looks at 2 arguments. So even Q would not be useful here, but it
right.
might
But
be.
so then in that case, what would be is something like #1 greater than. Well, actually, this would be a bad example, but let's say random. I mean, I don't think this will work, right? Because if I said something like that, right? But I mean, the idea would be that it would be something like this, right?
Right.
That's really nice.
But hold on. So this is basically just the, it's one of the. It's basically just one of the keys in this quote unquote meta applied thing. Yeah.
Right, but I mean, so probably one would have, for convenience, one would have some special functions like position applied or index applied. And then there would be a general meta applied where you could specify some whole collection of keys.
Right.
But the main issue is, what does the ambient function like select? Okay, how does it know? I mean, is this something that the evaluator would ultimately have to know? Because the evaluator knows, and this is going to come up in our discussion of multi-computation for those who are joining that tomorrow. This whole question about, during evaluation, what do you know about what environment you're in? Because right now, evaluation is context independent. Other than up values, which are the only kind of way that it can see context, so to speak. If there is a function, it just doesn't, this would be our first serious departure from context independent evaluation, which I think is something we're going to need. Go ahead.
I mean, there are lots of up values. I mean, there's stuff like nothing and splice. I don't know. I'm not sure this is the first departure.
Well, fair enough. But it's one that it's a more extreme departure because it really uses like the position information. And I could imagine, go ahead.
You could also imagine, though, that in the implementation of select, that it just checks, is my second argument position applied, and that would do an equivalent thing. So I don't know that this is really such a fundamental.
Well, all right, but fair enough. But I think
divergence.
I could imagine something where there is. I think is Nick here? If Nick is here, he might be able to comment on this. I rather suspect that a lot of things we've written that involve replace list, for example, would be a good example of something where, if you have a replace list and you say something like, X triple blank, Y triple blank goes to X, Y, and you do that on, range of 5 or something, that's going to give us a whole bunch of lists, right? But knowing, this may not be the best example. This isn't the best example. It's something where being able to annotate. In this case, it's rather obvious because but being able to annotate at what position a replacement was actually done, which otherwise we just don't know. I mean, if you say slash dot, right, if you have some expression, f of g of x and, g of y or something, you just say slash dot, g of, something like this. Those things absolutely do not know where they're being applied. Right? In other words, that thing, that u squared, is context independently generated here. Like, how would you write this code with anything like replacement so that it knows? So in the position applied world, what this would presumably turn into is something where you could say, now how would this work? Because this is a replacement rule. It's not a function. So I'm saying we want some.
Nikolai Merzen has something in the function repository that's called multi-replace. That's similar to this.
Multi-replace.
Okay.
Oh, he's here. Great.
Yeah,
he can talk about it.
It's a generalization of the replacement. It contains all the strategies and it can act on subsets and tuples independently, like at multiple positions. And it knows about the positions. Well, it doesn't know. It's like tries every combination. But if you want like a particular set of positions, then you have to come up with some different design. This is an older version, but I think.
Okay, so this one. Okay, so that's basically just looking at all possible parts in that first expression. So this is essentially something like a meta. This is what we've been calling something like a meta replace, except that here, instead of a function being applied, so we've got a bunch of functions like map and select that apply functions. We've got other functions that are in the replace family that run replacement rules.
Right. This
And
is
how
association replace indexed or something based on the names that we saw earlier.
Right, but the question is, how would you feed in to a rule like this? How would you feed in, to a function? It's fairly obvious that what you're doing is, I don't quite understand how you would add in.
Sorry, go back to the echo where example that I had before. So I think what I would do is to have the function in the second argument now of a rule. And then the function there is the one having to know where this has been used.
Oh, I see what you're saying. That makes
sense. The problem here is that this works like sequence. The function has a tendency to evaluate inside rule immediately. And so we have the same problem of sequence, that we have to use some sort of delay mechanism. And that's why I use this intermediate symbol echo where.
Well, but why isn't this?
Because by evaluation,
yeah, I understand. It would up value up even in the rule delayed.
Exactly. It would say I'm in the second argument of somewhere. So it's a bit like the difference between sequence and splice. So we need something that only evaluates in appropriate places.
Yes. I mean, by the way, I do think we should generalize splice to work to be able to specify the head in which it evaluates.
Yes, as a second argument. I'll do that. That should be easy.
Okay. Okay, but so then this has the same issue, and you're saying there'll be a collection of functions in which, I mean, one problem with sequence is we never sort of curated the functions in which we want it to. Well, we have, in a sense, we've hacked with sequence hold. We've basically specified which functions we wanted to evaluate and which ones we don't. Right? I mean, that's the
hold all complete also disables
desequencification. Okay, but let's look here. What do you have here? There. Okay, that was what we were talking about before. Keys for this. That's what we were talking about before.
Yeah, talking about
recap.
The similarities.
Okay. Okay, but so let's take a look.
Look at map function arguments.
Yeah.
Okay, so this is the option idea of Christopher's.
Mhm.
Yes.
Again, I mean, yeah.
I mean, I don't
I'm
like
not
the
sure
name
I like
map,
it.
but
I mean, the sort of the issue is that you'd like it if you didn't have to list, you know, if it could just detect the arguments. Because otherwise, it's such a pain. You know, it's so redundant. It's like you're saying, you know, map of f of expression comma index, you know, in expert, and then immediately after you say, oh, and by the way, the
No.
keys I need are expression and index. So it's kind of like, you know, yeah, you should be able to tell.
I think it should be a headdress of the F. I think this is crazy. I think this is one of these things where, you know, in a big piece of code.
not a headdress, right? A wrapper.
No, a wrapper of F, a wrapper of F. Because otherwise what's going to happen is you have a piece of code where F and expr are both long. Somewhere way at the end, you've got some weird option setting. It just doesn't seem right. I mean, this is something which you know about at the time when you say, oh, I really want that extra thing to be available inside my F. So put a wrapper that makes it available.
One other option, which is what a lot of other languages do, is they effectively have a wrapper around the expr, right? So something like, you know, a lot of languages have like enumerate. Like I think Python has this as well, where it's like you have your sort of iterator object or list or whatever, and you say enumerate of it, and that produces this other iterator that, you know, every time you ask it for the next, it gives you, you know, the index and the object.
Okay, so this is the options case. So we've got the case here, which is we've got the case where it is wrap the F, which is map of position applied of F, expr. And then we've got the other case, which is wrap the expr. Okay, so that would be, so the concept there would be, although conceptually, I see. So then it would be something like positionally. So
I think the idea is, I don't know what you'd call it, right? Okay, if you want to
positionalify.
Well, but the idea is that sits unevaluated. Maybe you could say like normal of that, and it would turn it into a big listy thing. But otherwise, it would sit unevaluated, right?
Yes. And then it would make, but you see, then what this would do, the conceptual thing this would do is it would turn it into A1 or A, you know, let's just say A1 if it was a indexified thing.
Right.
You know, something like this. At which point, then we still have the problem that map.
Well, or it could do this, or it could, in a more general case, if it wasn't positionify, if it was, you know, I don't know what to call it, instrumentify, it would turn each element into an association where it says expression arrow this, index arrow this, etc.
Metasaturate.
Metasaturate, sure.
What would that mean?
I have no idea what any. I mean, this is a very hard to name concept, I think.
Well, it may not be so hard to name. I mean, this is add metadata. Okay, so metaify. And then that's an interesting idea. So then what it does is it metaifies that to turn it into the association list, you know, expression goes to A. This is a good idea. This is I mean, it's a good conceptual idea, at least. Index goes to 1, etc.
Right, by default on the first level, but it could have a level spec.
Probably, yes.
Oh, that's a little horrifying, the level spec issue, because you'd like it to align with the level spec of map.
Right. So that's right. I mean, this works great at level 1, but I don't know what happens when you're mapping at multiple levels, because it just change the level structure of the expression.
This is similar to another idea we have discussed called coordinatize. Do you remember this discussion that we have an array of quantities and we want to say the positions because each one is a geoposition or a date or something?
Yes. What did we do with that?
I mean, it's on the works, but the idea would be that we had an array, then we would have a specification of how to coordinatize it with what. Mm-hmm. So it's a bit like a range. So we have an array, and then we say, use these min max to coordinatize a matrix. And then every element of the matrix will become a triple of x, y, comma, value. Or geoposition, comma, value. Or
sorry,
date, comma,
wait a second. Sorry, I missed something here. So that again.
Yes, imagine we have in the first argument a matrix of values, and in the second, it's a pair x min, x max, and so x min, x max, y min, y max. A range specification.
X min. Okay.
A range specification. So use two pairs.
Okay.
And so these would return now a matrix of triples.
Yeah, I get it. It's annotating with. It is annotating with the position. I mean, it's something again which one finds oneself. One often says map indexed of something like first of hash 2, comma hash ampersand ABCD.
Right. And then the third argument we had planned was one in which we specify whether we want a triple or a pair of position, comma, value, or an association,
yes,
or a rule, this type of thing.
By the way, it might also be possible, well, maybe it's probably too early to say whether this is possible, but using some of the Rob's data container stuff, it might be possible to get something that, would look just like this, and you could use, lots of different functions on it, but which internally it wouldn't actually have to make this big expression.
Yeah, that's a good idea.
And you wouldn't have to call normal on it to, or yeah, if you get what I mean.
Right. Okay, so hold on. So the basic point here, we've got the concept of putting a wrapper here that determines what gets fed into it, and perhaps these are, so the f of hash expression, comma, hash position could be provided both by this kind of wrapper and by something which is a wrapper on the expression, if I'm not mistaken. Or is that not the case? If the expression turned into a list, no, it still won't work. Will it work? Yes, it will work. If we turn this into, okay, in this case, right, if it turned out, if this meta-ify thing was, I mean, let's just write it. If we just say map indexed of, expression goes to, I hate that these are so long, but anyway, expression goes to hash, index goes to first of hash 2. Okay, and then we say like ABCD, we get this, and now what we want to do is to say we've now got our regular map, which says f of hash expression, comma, hash index squared or something. I see. So turning, if we had a function that simply turned the thing we're applying ourselves to, I understand there's a multi-level issue here. If we had something which simply turned it into this annotated coordinatified form, then this would just work. Right?
Yep.
At level 1.
At level 1. But that would that solve, okay, so in the select case, it would do the same thing. It would just work.
Hold on, but then what is select? If you're selecting over this object, I mean, shouldn't
yes, it
would return
the wrong
a list
thing.
of association. Yeah,
it returns the wrong thing. So it needs both sides of the transformation. It needs to transform into and transform out of. Okay, so that's a bit messier. So that's an argument for not having. That's an argument for dressing the function. This is an argument if you have. Well, okay, in the case of outer, for example, in the wrap the F idea, outer could then decide that this is position applied of F, comma, A, B, C, D, and then G, actually inner would be a better example here. that could be position applied, and G is a naked function.
It could also be position applied. So in principle, every function knows where it's being placed. And there is the corner case, which is the third point I was pointing out on the left, which is what happens if this position applied is used without a wrapper. That's the case that confuses me.
Sorry, say that again, Jose.
What happens if we just evaluate position applied of f of x? This is not wrapped by anything. So should it evaluate to something? Do we consider that it's at position empty list, which is the position of something in itself? So there is a corner case there, which is weird.
Okay, so position applied, you're saying of f of x.
Exactly. Should that evaluate or not? And to what? So my feeling is that this should be f of x empty list. But that can be problematic for other things.
That's a little weird. But you've also commented that
Right, that it escapes.
Could there be a stack position that's kept by the evaluator related to stack that this could just look at to figure out where it was?
My impression is that if it is a function, if position applied is inside one of the key functions like replace, select, map, etc., the function itself will know what to do with it. It will convert it into something else. And so we don't let position applied by itself do anything. If it's found in isolation, then it only looks at one level.
Yeah. But okay, but let's just come back to, okay, position applied or index applied or whatever it is, and perhaps both of those are useful. I mean, index applied, the top use of this is going to be top level, so to speak, first level. So index applied would already be very useful, even without solving in other words, if we had map of index applied of f, then we would have basically map index functionality. No, we would have first level map index functionality, I suppose. It's kind of icky that map indexed gives this positional thing. Okay, but then as opposed to position applied of this expr comma level 3 or something.
Right, but if right, that's not eating anything, so I guess that's okay.
Okay, yeah, but I'm still concerned about what other functions we think are relevant to all of this. Okay, so for example, fold. Is fold relevant? I mean, could we imagine something where we're saying, if we have, okay, so we're looking at other functions.
I've wanted a fold index a few times, I think. Like
yes,
when you know where you are in the list, yeah.
I mean, so this would be, so is that doable? I mean, in other words, if we say fold a position applied F.
Well, this is one of the issues with well, wait. I mean, so the two issues are that it'll get applied to a sequence, right? So is the position just like hash n+1, where n is the number of things that get passed into the position applied? And the other thing is that if we have this association-like case, maybe that's not how a position applied works, but it's how the other meta stuff we're talking about works. I mean, this is the same as the issue with map thread. I mean, what is the you have hash, and then you have hash position. I mean, you can't have both of those, can you? Right? So it's
yeah, that's an issue.
Yeah.
I mean, although
I mean, you could have something like hash expressions, and maybe that can evaluate to a sequence, or it can evaluate to a list or something like that. But it means you can't write hash right next to you write one of these other things.
I'm not completely convinced that hash can't coexist with hash position. It cannot if we think of it as an as-if association being fed in.
It would be an association being fed in, right?
Well, conceptually, but it might not actually be implemented that way, which might mean that hash could be sort of a partial thing that doesn't pick up the extra meta arguments in the association.
Kind of funky though. I mean,
It's funky,
yeah,
yes.
yeah. The other issue though is with something like position applied, where at least so far we've been talking about it as, it has #1 and #2. But if you use it in map thread, then it's #1 through n comes from the list, where that n could be anything, and then n plus 1 is the position.
Yeah, okay, I
right?
get it. Okay, so the issue is, okay, so map thread has the problem that the f here can take any number of arguments. And then the question is, where does this go? So list 1, list 2, list 3. So then the question is, where does a position argument for position applied go?
I have the impression that this is a bit like when we do listability, do we follow an inner model, an outer model? We have several possibilities. So this is a design choice that would have to be documented per function. So here we either append the position of the final object, or we append individually the positions of the individual lists, which would be of the same.
Right, which it reminds me also of the documentation of, color function or any of these other things in graphics where they are fed. I have to say, I think that's worked reasonably well. You know what I'm saying? I mean, it gets fed the X coordinate, the Y coordinate, the, some other thing, etc. Right? You all know what I'm talking about there.
Mm-hmm.
So, okay, so let's just look at a few other ones here and see what other things there are. I mean, fixed point would be amusing to give it this. That would be a thing where it could know how many times it's iterated, which otherwise I don't even know how you do. So I'm saying, I mean, in other words, if it says, well, similar to the fold case, that seems quite useful. A fixed point position applied. I mean, maybe we have to generalize the term position applied of f. If #2 greater than 100, g f g otherwise f.
Right, but I mean,
there's no easy way to do that otherwise, is there?
Probably not really, but it's also weird, right? Because you're looking at
a thing that hasn't been created
the position and
yet.
The expression. You're looking at the expression in this generated thing.
Right. You're looking, and this is something that's going to come up in our multi-computation design discussion. You're looking at this in this case, right? The position, the position in this case is created on the fly. It's not pre-existing.
It's a bit like the position in the fixed point list. So
yes.
Here we keep finding that it's either the position in input or perhaps the position in output.
That's correct. Which we could imagine, okay, so,
There's also nest, which I think is probably even more common than fixed point.
Yeah, I agree. Like nest indexed and things would be.
You'd almost say like an iteration applied instead of position applied.
Well, maybe that's a different function. Maybe
it seems like the goal here is to not have 100 star indexed functions. But
no. But what Bob is saying is perhaps position applied is that one is position of the input, position in the input.
Yes.
Whereas iteration applied, not the right name, I think, but iteration applied is position in the created output.
I just think this is kind of a fairly subtle distinction.
Implied created output in the case of fixed point. Right.
Yes.
Right. I mean, I mean, it
may not be necessary, to have this. But what about functions where there are both?
What about fold? Yeah.
Fold is an off by 1 for Sander is
Oh
commenting.
God, that's right. Yeah, because it has the first. That's even worse with fold.
Right. Fold has these basically off by 1. But I can imagine a bunch of these, like take while, or a bunch of these really being very happy to be able to pull in an index sometimes. I mean, array is pre-indexed, right? Array is specifically feeding in indices.
Yep.
Let's see, things like, okay, so let's take a look at some of these. Subset map. Oh boy. Well, that one, yeah, I don't think that one is so obviously has a, well, I mean, it might care which of these. Yeah, go ahead.
In the association case, I mean, almost all these functions have nice ways you could do it in the association case. Like here, you could have, position in the subset and position in the input list and stuff like that. It's just different elements. I think it's just if we're talking specifically about position applied, that is more troubled. Right, like in the harder cases, if we're giving a general association, you can change the keys and you can have more complicated stuff. It's just that having it be the position with a position applied is often not very well defined.
Yes. Okay, well, let's just see on here what other things. I mean, one could imagine accumulate having an index.
Accumulate doesn't take a function though.
Oh, you're right. Forget that. Forget it.
It's like moving map, which isn't on this list, but that's the general case.
Right.
In which case the position would be 2 elements, or many elements, the window size.
Yeah, it'd be the window, presumably.
The beginning,
but
the
that's
end,
again complicated. Yes.
Yeah, it complicates it. Is it the endpoints of the window or the center or what?
Be a span.
Yeah, a span expression.
That's really weird. You'd have to pull
weird.
apart the span. Okay,
if it's a pair of numbers, it's kind of ambiguous as if you're talking about a position.
That's true. What is Ian sending through here? Parafold. What is this?
So this was a response to a conversation on some mailing list. Fold taking the entire list of elements seen so far instead of just the next element.
Oh, I see. But isn't that like what fold? So that's like what nest while does.
Rather than like an additional argument, it's supplying a different argument than what fold normally gives, so that you have more information.
Right, which is what nest while and so on do. Fold does not have the apparatus that nest while. I mean, things like nest while. Okay, so for example, if we look at nest while, okay, we've got all these things here, right? Which fold does not have that possibility of a larger window, but sequence fold does, doesn't it?
Don't we have a fold while?
Let's see. But we have a sequence fold, which I have to admit I have not used. I bet I should have used this. I bet there's sequence fold. Okay, do we have a fold while? Yes, we do have a fold while, which again, I haven't used. I probably should have used this. I mean, in a sense, what we're suggesting here is an alternative to having to remember that the fold while exists, and instead have some kind of, well, would this thing that we're talking about with position applied, would it be able to do the extra arguments of fold while? Is that obvious?
Well, we can certainly invent some notation that fold sees and auto changes to fold while.
Mm-hmm.
But whether that can be generalized to other functions, it becomes trickier.
You're thinking
Yes.
like a wrapper on the F that would make
Yes, that's what I'm
F
thinking.
take the like the most recent M results. Like that's
That's weird.
That's something fold while does, but it doesn't necessarily need to only be fold while that has that capability.
Yeah, but it's weird. I mean, look, the other thing, if we're really going to generalize, the other thing is with map or anything which recurses through an expression, one of the things one doesn't have is access to the essentially express the tree stack above the part that you're in. See what I'm saying? In other words, if I do a like if I do this, if I say map, if I say f / at, you know, h of u of x, comma, and let's just for, oh, I don't know, u of j of x and y, then I will get this. But those f's, that inner f there, has no access to the fact that it is being called inside a u of an h or whatever. Do you see what I'm saying?
Yep.
Basically, instead of only a position, you're talking about having really the whole path.
Yeah, right. I mean, in other words, can there be?
What would that mean, though? I mean, isn't that not just the same thing as mapping at a higher level or like a lower level spec?
No, because you
apply
actually
here, but take into account something
right.
at a higher level.
But what does take into account? I mean, how is it going to tell you what the context is without just providing that expression?
Well, it could tell you the heads, for example. It could be like the stack trace. Oh, I see. You're saying, could there be a hash, you know, head path or something, and maybe that's not useful.
That's also called stack. And if you do stack inhibit of map of blah, 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 you know, and then inside your F you call stack, I think it'll basically do what you're saying.
Okay.
But it'll include the F's in it. If they're, you know, if you're doing map all like this, it'll include the higher level F's in it. But
okay, but you're saying, I mean, what we might be saying here is, could you get a U of whatever it is, a list of H of U, something like that. In other words, this would be a way, if you wanted to implement up values in /dot effectively, this would be the way to do it. So yeah, we're going to have to wrap here in a moment. This is a really interesting discussion, and I think it's clear. Okay, it's clear. My guess is that something like position applied and a generalization of that are going to be what we'll end up finding will work, and that will define how it works in particular functions. And that's an alternative. It's a more factored way of not having, you know, all sorts of separately named functions. Sandra is commenting that drop while will be a useful thing to have. Useful for deleting headers. Well, that's interesting. That's a good point. Yeah, drop while it's white space or something. It's a good point. Well, that's a reasonable thing for us to consider having. People agree?
Okay. Yeah, there's actually a Wolfram function repository instance of it that we're going to review at some point. It might actually be on the list here, but yeah, we'll look at it another time.
Okay. All right. We probably should wrap up soon here, unless somebody had I mean, to me, this is we've got more work to do. And in particular, I think an important thing, I think this issue about metadata is separate from the issue about association returns, separate again from the parallel thing, which the parallel thing just seems to me like it's going to be a headdress. Anybody disagree about that? I mean,
maybe one point is that parallelize could be repurposed as a headdress in addition to what it already does, or we could introduce a new.
Well, you could say parallel applied or something.
Yeah.
We could say parallel applied of select, of whatever.
My only skepticism about parallel applied is that it sounds a bit, the other functions that we have that have like apply in the name, like curry applied and operator applied or whatever they're called. I mean, those really take anything, and they're kind of nothing combinator functions.
Fair enough. Parallelized. You're suggesting that we might that we might have.
I'm just saying. I mean, we could have. I mean, the other obvious one would just be parallel, but
yes.
But we could also just reuse parallelize.
I would say parallelize has not been a grand success at this time. I mean, parallelize in principle, because I just don't trust it. I don't know when it's going to work. And for example, if we had parallelize select and it gave me an error message if there was no parallelization available, that would be more useful to me. Or alternatively, if the thing had a syntax coloring that made it clear that this just wasn't going to work.
By the way, it does give a message. If it says cannot parallelize this, reverting to unparalleled sequential evaluation or whatever.
Okay, but so if I say parallelize range of 1,000, something like this, comma, prime Q or something like this, is that going to do anything? Oh, for God's sake! Well, oh no! Come on. Ugh.
I always manually launch and kill the kernels because I don't like orphaned kernels running around after this finishes.
Are there orphaned kernels?
I thought there were. I thought it doesn't kill them because then that way when you call parallel map again, it'll be fast.
Oh yeah, right. No, it doesn't kill the, yes, but I mean, they can zombify, for example, well, the question is if you kill this kernel, if you kill this master kernel,
then they die. Yes.
They're supposed to die. They don't always die.
I've rarely seen them not die.
Maybe I've certainly had cases where they, yeah, I've had cases where they don't die. But okay, now what did this do? Did this parallelize? Well, did it in fact parallelize anything, or did it just, what the hell did it do? Anybody have any idea?
Try calling association map instead, because I'm pretty sure that one, it won't parallelize it, and you can see what it does. I mean, the arguments are the wrong order, but it doesn't matter. Yeah.
Huh. So you think it actually parallelized the select?
I can't say for sure, but I mean, I don't think, let me look at the documentation. I don't think it ever gives you a list of what it can. Yeah, there's no list of what it can parallelize. Which is a little bit.
That's crazy. That's crazy. I mean, so if I said here, let's see, how could I do this? I could parallelize, if I did a select, how do I get the machine name in here?
You could just select, well, actually,
less than $kernel ID or something. Or
why don't you just echo the kernel ID along with the prime Q?
Okay.
Don't forget the ampersand after machine name.
Look at that. What do you know? I had no idea. All these years, I had no idea. I've written all kinds of code that, sort of pre-prepares. What the hell? Wait a minute. Oh, well, yeah, that's plausible. There were 1,000 of those. I'm just want to try something else here. Well,
so by the way, another question, because this is an even more basic thing about parallelized, I don't know. Does it always, I thought it like drilled into the expression and tried to find stuff that could parallelize, but does it, like if you had f of select, would it still work?
Let's find out.
Yeah.
By the way, this example or some example like this should be in the documentation.
Or maybe reverse of select or something. I don't know. Something at least evaluates.
Oh,
okay.
Very fascinating.
I didn't know that. Okay, so it looks like it just.
So it at least tries to look at it. By the way, I would have thought compiler technology should be able to assist this greatly.
In what way?
Well, being able to figure out from type information what might be parallelizable.
Oh, well, okay, but actually this is a more deterministic function than I thought it was, because I thought that it did much more heuristic stuff, drilling into expressions.
So did I. I mean, honestly, I've never used this function because I didn't trust that it did anything. It was supposed to be the be-all and end-all function for parallelization. Yeah, it just doesn't say what it parallelizes. It just has no information here.
I mean, the other thing that's a little frustrating is that there are certain parallel behavior that's only accessible through parallelize. Like, there's no parallel map indexed, but I think you can say parallelize of map indexed, and that works.
The thing that should happen, at the very least, we should have some kind of syntax coloring here. So that if you type parallelize of select, because it's only going to work lexically anyway, basically. I mean, you could feed it in with some weird, pattern matching and so on. But otherwise, most of the time, it's when you're literally typing parallelize of something. I mean, we don't currently have, we only have discoloration if things fail. We don't have discoloration if they succeed. In other words, it never goes more black than black, so to speak. If that makes any sense. But I could imagine a situation in which here, this somehow indicates that it is going to work. I don't know if anybody has can we take that to the user assistance meeting? And for goodness sake, we got to get parallelized to at least document what functions it works with.
What about having it go light or black, grayish when it won't work?
That would be fine too. That would be nice. Have the select gray out if it isn't going to work.
Right.
That would be fine.
Even turn like red, but that might be a little bit weird.
I don't think it would be
like
terrible.
If you had reverse of select, the reverse would be red.
I'm not sure it wants to be red because it's going to give a message, but it would work. I'm not sure. That's a detailed question, but I think the first thing is to make sure that we know in parallelize what. Yeah, because I mean, this parallelize functionality is perfectly, if one could trust it, it would be perfectly reasonable and one wouldn't need the head-dressed functions.
What if you could get it to give you back a report when it was done with like a second argument and it says, this kernel X was used to do this and kernel Y was used to do that?
Well, that's basically the analog of timing for parallelization.
Right.
Which is an interesting idea in its own right. That is timing, for example. I mean, I have no idea what timing does when things are parallelized. What does timing do when things are parallelized? If I say parallel evaluate of pause of 1 / absolute timing, what the hell does it do?
That just measures the clock time of when you start it, when you finish it.
Yeah, absolutely.
I see. Sorry, I should have been trying timing.
Yeah, timing is different from absolute.
That's utterly mysterious. Because, I mean, this question of whether timing I mean, do we have any capability to measure total CPU time? Anybody know? I mean, that seems like an important thing for our parallel stuff to know what the total CPU time.
There's a question of whether pause should be counted as CPU time, isn't there? I mean, I don't think it's supposed to be.
Okay, fair enough. Fair point. I mean, is so that's even more mysterious. That's
absolutely correct.
No, this is correct. But then what did this do?
Maybe it's 0.7 seconds of overhead of some
The
kind.
overhead, exactly.
Right.
And the
that's all
overhead might be
communication
multiplied by
between
the
the
number of
different kernels.
Yeah.
Well, so if I say timing here, what I'm going to get is
maybe do timing part 2 so you can do total of it in a minute.
Yeah.
But again, it might be the it might be the actual operation of parallel evaluate itself.
What did I just do?
Part 1, not part 2.
Oh yeah.
Okay, so
maybe do total of parallel evaluate, // time. Okay, fine.
It's weird that the first one is so much larger than the last one, isn't it?
That's the communication overhead between the kernels, I think.
Right. That's the CPU time this kernel spent sending out and receiving answers.
Yeah.
Which kernel spent? The timings
The
are done on the remote kernel.
No. The first argument to
within the second argument
output.
Within the second argument, the values are almost ordered, and the first one is so much bigger than the last one. That's what's freaking me out.
No, that makes absolute sense. Each subkernel spent a fraction of a second CPU time doing pause of 1. The master spent 0.7 whatever second.
Yeah, and they're not exactly ordered.
No, it's just different computers. Yeah.
That last one is kind of large, Bob.
Yep, I get it.
Correctly.
That helped. That cleared everything up, that plot.
What does the plot mean? It just means
it means that you have different computers.
You have 5 different computers with that many kernels on each one, right?
And different
some are faster than others.
Yeah, so the last ones might be your local kernels or whatever. Yeah.
Yeah.
But I guess maybe a question would be, so if parallelized can just be better documented so that you know what it works on, is there still value in having a headdress, maybe also called parallelize?
Possibly. But I think let's start off by documenting it and see whether we actually have decent coverage. And I think
there is definitely missing stuff like association map. Like I run into missing stuff fairly routinely.
Okay, but then let's get it documented. Let's get some kind of syntax coloring feedback of whether it's going to work. And that's the place to start. By the way, this will make a nice example if somebody for parallel evaluate. Well, I don't know exactly what one wants to do, but this is kind of a cool thing.
Most people will not be able to reproduce that plot locally.
Yes, I realize that. Okay, let's see. And I need to run off actually, but we need to continue this discussion, and maybe we should have a slightly longer custom meeting specifically about this position applied stuff, which I think we're going to be able to nail. I think it's going to be good. All right. Anything else quickly now?
Nope. I think they're going to work on putting something together.
Sounds